In this video, we will be discussing how to find or to determine whether a function is even or odd using both the equation and the graph. Now, a function is even if f of negative x is equal to f of x. To make this more clear, let us have an example. Supposing we are given f of x is equal to 2x squared minus 5. What you want to do here is to assume any value for x. Say, for example, x equals 2. So if x is equal to 2, then that means that negative x is negative 2. If f of 2 is equal to f of negative 2, then we say that the function is an even function. So let's go ahead and evaluate the function at x equals 2. Now, to evaluate the function, remember we have to plug in 2 in place of x. So the function now becomes 2 multiplied by 2 squared, because x is 2, minus 5. Let's do the exponent first. So you have 2 multiplied by 2 squared, which is 4, minus 5. 2 multiplied by 4 is 8, minus 5. So f of 2 is equal to positive 3. Now, what about f of negative 2? The same thing. We will plug in negative 2 in place of x. So the equation, this function becomes 2 multiplied by x squared, or negative 2 squared, minus 5. We get 2 multiplied by negative 2 squared is the same as negative 2 times negative 2, which is positive 4, minus 5. 2 times 4 is 8, minus 5. So f of negative 2 is equal to 3. So we see here that f of 2 is 3 and f of negative 2 is also 3. Since f of 2 is equal to f of negative 2, therefore, this function is an even function. So another one. When is a function an odd function? A function is odd if f of negative x is not equal to f of x. Instead, it is equal to negative f of x. This means that you get opposite signs. Let's get an example. Supposing f of x is equal to x cubed plus x. Again, let's assume any value for x, but for this purpose, let us say x is equal to 2. Again, negative x would be equal to negative 2. So, what is our f of 2? We're plugging in 2 in place of x in our equation. So you'll have 2 to the third power plus 2. 2 to the third power is 8 plus 2. So our f of 2 is equal to 10. What about f of negative 2? So we're plugging in negative 2 for x. You'll have negative 2 to the third power plus negative 2. Negative 2 to the third power gives us negative 8. Negative 8 plus negative 2 is negative 10. So our f of negative 2 is negative 10. F of 2 is positive 10. F of negative 2 is negative 10. The signs are opposite. Therefore, this one is an odd function. Now, even without calculating the values of the function, you can just look at the exponents. If all the exponents are even numbers, now 0 is considered an even number for this purpose. So that means the constant has an even exponent, x to the 0. So that means let's look at the first one. The exponents are 2, and then you have a constant, the exponent of which is 0. Both are even numbers, so this function is even. For the second one, the exponents are 3, which is an odd number, and 1, that invisible 1, which is also an odd number. That means this function is an odd function. Now, if you have a combination of even numbers and odd numbers for the exponent, then that is neither odd nor even. For example, say you are given f of x equals x to the fourth minus x cubed plus 2. Let's look at the exponents here. The exponents are 4, which is an even number, 3, which is an odd number, and then you have a constant. The exponent of the variable here is 0, which is an even number. So you have a combination of even, 4 and 0, and the odd number 3. Therefore, this function is neither even nor odd. So that is how you find or determine whether a function is even or odd from the equation. Now, what about if you have a graph? If you would look at the graph, a function is an even function if it is symmetric with respect to the y-axis, or if it is reflected over the y-axis. You have an odd function if there are two reflections. It is reflected over the y-axis and then reflected once more over the x-axis. Or in other words, it is symmetric with respect to the origin. All right, that means you will rotate this. If this is rotated over the origin, then you have an add function. Now let's look at the first one. Okay, this is our y-axis right here. This side of the graph is mirrored over to the other side. So there is a reflection across the y-axis. That means this function is an even function. Now, if you would look at the point, say, this point right here, that's 1, 2, 3. That's 1, 2, 3. So this point is, am I right? 3. If x is 3, then y is also 3. And then if x is negative 3, then y is also positive 3. So for this one, f of 3 is equal to f of negative 3. Both of them are equal to positive 3. So the reflection is over the y-axis. Now let's look at the other one here, the other graph right here. Okay. If you take this part of the graph, it's not reflected over the y-axis, but let's draw its reflection over the y-axis. So you'd have something like this, right? I just extended it up here. So that is the reflection over the y-axis. And then this part of the graph, okay, is reflected over the x-axis. Therefore, this one here is an odd function. Go ahead and identify whether the following function is even or odd, or neither. You are correct. This function is an even function because the exponents are 4, which is an even number, 2, which is an even number, and you have a constant, which is considered an even also. So this one is an even function. What about this one? Is this function even or odd? All right. So let's do the reflection over the y-axis. We know that this is not even, but let's see if this is an odd function. 1, 2, 3, 1, 2, 3. So that point is reflected right here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This point is reflected right here. Okay, so when you reflect that over the y-axis, you have this. And then when you reflect this graph over the x-axis, you will have this. So you reflect over y, and then you reflect over x. Therefore, this one is an odd function. I hope you get it.